Hi, welcome to the presentation for Eval-UA-tion, a benchmark for the evaluation of Ukrainian language models. My name is Serhii Hamotskyi. I will start directly with the motivation. So Ukrainian use is increasing, especially since 2014, but especially strongly since the outbreak of the full-scale war. And this can be seen, amongst other things, in opinion polls. And here we see that the share of Ukrainian read keeps increasing still. At the same time, there was a really nice paper done in 2020 about languages inclusion and in NLP, and it placed Ukrainian in group 3, languages that have a thriving online community, which helps with pre-training data, but let down by insufficient labeled data. And one of the goals of this project was to create additional labeled datasets. Ukrainian remains a challenge for large language models. I think everyone here has seen this one way or the other. In the context of this project, we generated stories with GPT-4 and Gemini and then manually corrected them, and every single story had errors in the language, mostly clearly coming from Russian. And smaller large language models are having even a harder time, and this specific screenshot, the prompt here is only partial, but the idea, write the story in Ukrainian, start with the words одного разу. It starts with одного разу and then keeps writing the whole story in Russian. And this was one of the motivations to start this project to begin with. One of the reasons why is that Ukrainian is an inflected language. So one can see languages in a continuum. On one side, analytic languages like English, which show grammatical relationships by adding more words. I will go home. On the other side, you have languages like Ukrainian, which much more change the words themselves. Піду додому. And the Ukrainian піду contains all the information from the English I will go. One way to show this is through such notation, with the Ukrainian word, the translation, and the grammatical abbreviations. Here, first person singular, I, and future, will. I will go. This has many implications for this project, as we will see later. So, the tasks themselves. Evaluation is a set of 3 benchmark tasks, 9 datasets in total, each having at least 1000 examples and with human baselines to evaluate large language models. Which I will describe right now in detail. Starting with UA-CBT, Ukrainian Children Book Test. It is a fill-in-the-blank task where you have a story, you have a word, you mask this word, and then you have 6 options to choose which words should be instead of the gap. It has 1061 instances based on 72 different stories, all generated by large language models. And this is a sample translated task. This is an absolutely horrible story, but the key bit is here. When the user heard the story about the death of he became angry. And to pick which is the correct answer for the gap, one has to understand that both the snake and the hunter are dead, but the user hired the hunter to kill the snake. So he will be sad about the death of the hunter, not of the snake whom he wanted killed. And this was the intent behind these tasks. The 2 complexities here were problem number 1, inflection. This is the same story as before. We get in the mindset of creating such tasks automatically, and we try the first logical thingy. We find all nouns for the gap, and we just put them inside the option. And here immediately we can see the problem with this. Because почувши історію зі смертю, лихвар, почувши історію зі смертю, осел, this does not work on a grammatical level, and one can directly exclude 5 of the 6 options. And to force language models to actually think about the content, they have to be inflected, changed to fit the gap. So here, based on the context, we know that it should be genitive case, and we inflect all the words to agree with the surrounding ones to genitive. Fermer to fermera, for example. Problem number 2, disambiguation. Here we have мисливця, and we want to use it to inflect the other options. The problem with this is that if we don't have the context, for example like this, then We cannot tell whether мисливця is accusative or genitive, родовий чи знахідний, because both options here are identical. Знайшов мисливця, смерть мисливця. If we guess incorrectly and pick the wrong one, and then try to put there another word and inflect it to the wrong inflection, if this word is different in both cases, then we will have errors. For example, змія is different in accusative and genitive. And if we try to put Istoria зі смертю змію, it will be immediately wrong. And this topic of disambiguation featured prominently, and it's not just cases. For example, три can be both a verb and a numeral. How this was solved? Yes. This was solved by we used bimorphy to do most of the work, and first doing morphological analysis with bimorphy. Bimorphy gives n different possible options, 3 as verb, 3 as numeral. Then we used Serhii, which uses contextual information, to pick the bimorphy parse as close to what Serhii thinks as possible. So using Serhii to disambiguate bimorphy parses. This became a separate package. Hopefully it might be useful for the community. Next, generating stories. Stories were generated by with GPT-4 and Gemini Pro. And the first attempts were to use simple prompts, write a story about X and Y. The first X and Y was Fox and Raven, and then we discovered that GPT-4 knows only one story involving a fox and a raven. A very famous story which always ends with the fox stealing cheese from the raven. To combat this memorization, we used more detailed prompts which were generated. This is a partial file to do this. And then we would have things like a tricky mouse not learning anything, or a lazy turtle proving they are a good tailor. And the idea was that if this is detailed enough, then the LLM will be forced to create a story instead of using one which it already knows, to combat contamination issues. Generating stories. GPT-4 and Gemini. In our impression, GPT-4 was better at following directions, number of characters, lengths. Gemini had better Ukrainian language. So we used this flow to take advantage of both. GPT-4 stories got error corrected by Gemini, and Gemini stories, there was a first version. We always asked make the story longer. Then it created a longer story close to the required length, and then still error correction, and then all stories were manually corrected. We used English language prompts for this, and half of the prompts asked for unhappy endings because in our impression this forced it to be more creative. The stories and the tasks were manually filtered by humans, leaving 62% of stories which then went through manual error correction, and 75% of the task instances which we wanted solvable task instances. So without unknowable answer, without multiple answers, etc, etc, etc. That was it about UA-CBT. Next, LMentry-static-UA. This is based on an existing benchmark. And the aim is to do tasks which are hard for large language models but easy for humans. And there are 3 basic groups of tasks. One's asking, for example, what is the 5th letter in this word, one's about categories, and one's about comparisons. Let's look at all of them in detail. But before this, one of the focuses of this task was robustness. And this means that there is a lot of metadata about, and that the same individual, for example, words use different templates to ask the same question. So which word is last alphabetically, which word is closer to the letter Ya in the alphabet, etc, etc, etc. So let's start. N in M type tasks. What is the 3rd letter in the word pizza? What is the 5th word in this sentence? This sounded easy until numbers, Ukrainian grammar, and the realization was that if we are asking for the first word, then it can be літера номер 1, слово номер 1, перше слово, слово на першому місці. And then we have again to do this kind of inflection. We wrote a package for this, so the template contains still the numeral, every time it is parsed disambiguated, and then using this package, the package requires a natural language numeral and an integer, and then it puts the integer into the same shape as the numeral. So for example, 15 returns 15th. It is also available on GitHub. Then, category-based tasks. They were relatively easy. We have seen a similar task in the UNLP shared task for language models, no relation. I think we both just had the same idea here. 5 options, 11 categories, and comparison-based tasks. Which word is longer, which word comes first in alphabetical order. So here, those are not translations, just examples. And here, again, robustness, different templates, asking which word is longest, which word has more letters, and then here was interesting that Ukrainian words contain hyphens and apostrophes. And then the question which word is longer and which word has more letters may be different, depending on whether you consider hyphens and apostrophes letters. To go around this, we just removed all words containing those symbols. And lastly, Ukrainska Pravda titles. Ukrainska Pravda, the online newspaper. We scraped 2 years of articles, and the idea was to match an article text to one of 10 similar titles. 2 versions, unmasked and masked. The masked option, if you see the same number in the title of articles and in an article text, then you know that quite likely they match, regardless of any language understanding, regardless of whether it's soldiers or rocket systems. So we just decided to remove all digits to force to understand the content by removing this simple option. And then it looked like this. This task is still solvable easily, but it's a bit harder than if one could just take the numbers behind the x's. Baselines and human evaluation. The baselines for all tasks were calculated, both random ones and human ones. The interesting bits here are that the Ukrainska Pravda articles have the lowest human baselines, and that humans also found the masked dataset harder than the unmasked one. And for the tasks where a different number of words in the sentence, different numbers of letters, we just use the average number of options to calculate the random baselines. The stories for UA-CBT and the tasks for UA-CBT were filtered fixed in Label Studio, but the human baselines were done using a Telegram bot. And this worked really nicely, actually. So on the left you see it solving something, or a person using it to do a human baseline. There were small gamification bits with sending random emojis of food. And this honestly worked well. This was much easier to use on mobile, and all the annotators who had a preference, all of them liked the bot more than a Label Studio. And this is something which we will also use in the future for similar projects. The bot is available on GitHub. Experiments. We use the LM evaluation harness for this, which does not support instruction prompts, which is a drawback of the process. And we used 5 models, 2 GPT ones and 3 models based on Mistral. The vanilla Mistral unchanged, and 2 models, the last of which, Sherlock, is the winner of the UNLP shared task. We did not know this at the time, but there are few Ukrainian language models on Hugging Face, and Sherlock worked really nicely. So the results: GPT-4 clearly wins, followed by GPT-3, but Sherlock outperforms GPT-3 on 3 of the 8 tasks, or compares to it, but Sherlock has 25 times fewer parameters than GPT-3 to use the same, to solve the same task. So this is really neat. Except for this, UA-CBT worked really nicely, GPT-4 spectacularly outperformed everyone on the UA-CBT task here. The first idea was that since it generated some of the stories, then maybe there is some contamination involved, and of course it's better at it, but it also performs better on stories generated completely by Gemini. So it is not about this simple case of contamination. And Sherlock performed really nicely, better than GPT-3 on the 2 Ukrainska Pravda tasks. The masked task was also harder for models and for humans than the unmasked one. Conclusions. We created 3 different tasks using different in the content, different approaches. This was really fun to do. This shows that Ukrainian fine-tuning on smaller language models works, helps, and we should do more of this. And in the future, we'd like to definitely evaluate more models, especially Gemini Pro, which would be very interesting also to look into contamination. And I think that's it from my side. Thank you very much. The dataset is the code for this is available on GitHub, and the links to all datasets on Hugging Face are also there. Thank you for your attention.